Today we'll do few other things, okay?
Yes, sir.
Did you check the notes which I've sent you?
Yes, sir.
Okay, today we are going to do what? Mean value of binomial distribution. Clear?
Yes, sir.
So what was the mean previously? What we have done? What was the mean? How you used to find the mean? I think we have discussed previously.
Yes,
You all
sir.
remember how we have done? How we have done? In quantum mechanics itself, I think you all have done. To find the expectation value.
Yes, sir.
So how do you usually find that? By considering what?
Wave function.
Mean is given by what?
Mean is given by what?
You just write this is given by summation over all n's in probability of finding n. In this manner, did we do previously? If you all remember, this is the mean. Okay. I think I have done the example also. Please check the video. So after this, what we can do? For the binomial distribution, the probability was given by what? Probability distribution was given by what? N factorial divided by n factorial, n minus n factorial, p to the power n, q to the power n minus n. So this was the binomial distribution, was it? Was this the binomial distribution?
Yes, sir.
So next what you'll do? You have to find the mean. So the mean is given by what? Summation over n's n factorial divided by n factorial p to the power n q to the power n minus n. Now what to do after this?
Sir, we have to compare that too.
Now if you compare with this, what there is an additional n which is sitting over here. Clear? Now next what we can do is, we can write the same thing as what? Summation over n this p, what you can write? Can you write in this manner? Or let's go step by step, okay? N factorial, can we write this? N into n minus 1 factorial. Can we write this?
Yes, sir.
Okay. This n will cancel out. Is it clear till here?
Yes, sir.
And for this p to the power n, can we write in this manner? dy dt of p to the power n plus 1. Suppose if we write this, what we will get? N plus 1 if we take the derivative of d by dp of p to the power n. What we will get? What we will get? Or if we take the derivative of n plus 1, what we will get? N plus 1
Plus 1
times p to the power n.
plus n.
Is it fine till here?
Yes, sir.
So p to the power n to p to the power n, can we write in this form? 1 divided by, sorry, this is not p, this is n plus 1, no?
Yes, sir.
N plus 1 into
P to the power n.
n plus 1 by dp. Can we write in this form?
Yes, sir.
I think it's fine till here. Is it fine?
Yes, sir.
So next what we can do? Next what we can do? Next what we can do?
Normalize.
Not normalize. Now can we put this, after putting this, what we will get inside here? D by dp of p to the power n plus 1. Will it be this? Is it fine or not?
Yes, sir.
But I think there is something wrong. Or is it correct? Now after substituting, what you will get? This into what? Q to the power n minus n. Clear? So this derivative, I think we can take it out. And should A also, in addition to that, we will have what? N plus. Good morning. Do we get something like this? With derivative sitting over here.
Sir, can you just give a brief from first?
Where were you?
Sir, actually electricity problem, sir. I was charging my phone in car. I just got back home.
Okay, actually what we are doing is we are finding the mean of binomial distribution. Clear?
Yes, sir.
The mean is given by what? The mean is given by what? The mean is given by what?
P n equals to
Okay. N equals to summation of n is from
n.
overall n, n, p,
Okay.
n. No? Something like this. So actually what we were doing was till now is n is given by something. N is from 0 to n, n factorial divided by what? N factorial, n minus n factorial, p to the power n, q to the power n minus n. Now this was for the binomial distribution. This was the thing. Now can you see in addition we have this n sitting over here.
Yes, sir.
So what we can do? If we write this as partial derivative of p summation over all n factorial divided by n factorial n minus n factorial p to the power n q to the power n minus n. Can we write in this form?
So above n,
Hmm?
that small n, sir.
Which this small n, the derivative is sitting over here. What it will go?
Above one.
Hmm?
Above one, sir.
This one what?
Numerator. Yes,
Which?
sir. Small n.
This n we are considering this by considering this derivative.
Yes, sir.
How? But how? How?
How, sir?
Now, you know, inside this, what this is given by what? Basically a probability. This can be given by a probability.
Yes, sir.
If you just, everyone, you just take the derivative of this. You just take the derivative of this. Everyone, prove this, whether this equal to this or not. Everyone do that exercise now. Are you doing? Everyone?
Yes, sir.
Okay. I think that will not come. Is it fine till here? Is it fine or not?
Yes, sir.
You'll get this. Most probably not.
No, sir.
No,
Okay.
sir.
What is the difference? What did you get, Indira?
Yes, sir.
If you take the derivative, what you will get? There will be n minus 1 will be here.
Yes, sir.
Actually, what you are getting is something like this. If you take the derivative, what you will get? N into p to the power n minus 1 q to the power n minus n. So you are getting something like this.
Yes,
Yes,
sir.
sir.
And if you check this, something is correct. Something is correct. N is already there. It's exactly looking like this, but instead what you have, this only this power is not matching. Can you see? You compare with this one. When you compare with this one, only this power is not matching. With
Yes,
not
sir.
this
sir.
one, sorry, with this one. So in that respect, what we can do is, we had what? N into n factorial divided by
Divided by
n factorial
n,
n minus
n
n
minus
factorial
1
p to the power n q to the power.
power n minus small n.
Okay. Now, at least everything was coming out to be fine, but something, only the power of p was not matching. Clear?
Yes, sir.
Now, what we can do is, can we do this? And remove this. Can we do this?
Yes, sir.
Just check, okay? Now, if you take the derivative of this, what you will get? If you take the derivative, you will get what? N p to the power n minus 1. Clear? And if you
Yes,
multiply with p, what you will get? N p to the power n. Now, I'll just write this and I will let you know. Indira, is this correct? Indira,
Yes, sir.
is this correct?
Mm-mm.
Now, if you compare this two, okay. Now, if you compare this and this, previously the power of what was not matching? If there was no p, p was coming with n minus 1. Clear?
Yes,
But
sir.
over here, what we have outside, p is also sitting out here. Because the summation is only in n, p is already sitting over here. So this will go and multiply. If we simply multiply p with this, what we will get? N factorial, n factorial, n minus n factorial, p, basically, p to the power n. Because p is multiplying with this. Minus 1 plus 1 it will be, no?
yes, sir.
So basically you'll end up with that one. So what we can write is, in a similar fashion, we can write in this manner. Now is it clear? How
Yes,
we
sir.
can write this to this? Clear?
Yes, sir.
Now the main thing is what? After doing this, what we can do is, this is basically what? Here, this whole thing.
Summation of.
It was whatever you started with, probability of n. This is exactly that binomial distribution. Can you see?
Yes, sir.
Clear?
Yes, sir.
Indira, is it clear? And remaining students?
Yes, sir.
No. Is it clear or not?
Yes, sir.
Okay.
Clear, sir.
So after this, what you can do? So the mean is basically given by the derivative. Can you see? But you already know you can write this in this form. Summation of all the probability, what you can write previously, I think we have done, you go and check. So that's why p plus q to the power n. Now if you take the derivative, what you will get? P derivative of this will be what? N. That's it. Into p to the power, p plus q to the power n minus 1. Clear?
Yes, sir.
Yes,
So,
sir.
or the mean will be given by p into n. Because
So
you
that
know,
n is the power, so that came front, no, sir?
yeah,
After
that is the
derivation.
power after derivative.
Yes, sir.
So
Yes, sir.
this will be basically this one, because you know that p plus q was basically 1. This is how you have defined p plus q. So that's
Yes,
why
sir.
your mean is given by basically p times n. Clear?
So what about n minus 1, sir?
Which 1 to the
The
power n
power
minus 1, 1 to the power anything is what?
It's a 1. Yes, sir. Got it.
Okay. Is it clear?
Yes, sir.
Yes, sir.
Okay, then after this, what we have to do next? Limit of binomial distribution. Okay, there are the two limiting factors for binomial distribution. How many limits? There are two limits for binomial distribution. At particular extreme, how the distribution will look. Clear? Now let's consider Can you see this?
Yes,
Can
sir.
you see?
Yes, sir.
Yes, sir.
When L is only the problem is when n is extremely large, what you will have? you'll have what? You'll have very hard time calculating those things. Clear?
Yes, sir.
I think I have to go back and forth, so I think I will share the entire screen. Okay. Can you see now? Can you see?
Yes, sir.
Now there are two
Yes, sir.
limits to what? To a binomial distribution. Because when n is extremely large, what will happen? When n is extremely large, what will happen? Nothing much if you think about this. What will happen is a binomial distribution, or can I write P or B? Okay, it's either way, it's fine. It's basically n factorial divided by n factorial, n minus n factorial, p to the power
N
okay.
q to the power n minus n.
Suppose, let's say when you have this n extremely large, okay, then what you have to do? You have to, let's say we have n is equals to 50. Now you have to find the factorial of 50. Clear? Now it's very hard. Now how many times you'll do 50 into 49 into in such a manner? Suppose the number of particles is about 10 to the power 30. Clear? Or 10 to the power 20 kind of. In this range, now it will be extremely hard to find the factorial. So that's why we will consider the limits. Clear? When n is extremely large, clear? And depending on the limits, we'll get two kind of distribution from binomial. From binomial, it will end up into how many? Depending on two different
Sir,
limits.
it will be very much difficult to calculate, sir.
Yeah,
if
so
n is
that's
large.
why. So that's why we'll be considering some different limits. Clear? In this limit, we'll get some kind of different distribution. Now your binomial distribution will depending on the particular limit, it will give you two different what? Distribution. One is called Poisson's, which you have already heard, Poisson's distribution. And another one is your Gaussian. Yeah.
Yes, sir.
Is it clear, everyone?
Yes, sir.
Where have you heard about this? Poisson's? Have you heard somewhere?
Mathematics.
In mathematics also, apart from that, electrostatics, Laplace,
Poisson ratio only, sir.
Laplace and Poisson's equation. I think you have heard.
Poisson's
For
ratio
charge free and with charge. Okay.
Yes, sir.
Yes, sir.
Now suppose n is large. Now it will be very clumsy to calculate the quantity like by using what? Binomial distribution. Clear?
Yes,
Suppose in a room, let's say we have how many particles? In a room, we have n is equals to, let's consider the example which I have given to you all, okay? Now let's n be basically what? Can you see? I have n molecules of air in the room of volume. What was the volume given? V. The molecules are distributed uniformly in the room. Now this is very important. Are uniformly in the room. Clear? In other words, the number density denoted is same in the every point in the room. Clear? Consider now an imaginary small volume which we are considering. Now out of this experiment, whether the particle will enter into this will be in this small volume or not. That is the question. Clear?
Yes, sir.
Yes, sir.
Now there is a room which has a volume of what?
V.
Okay, which has a volume of V. And you have a small arbitrary volume. Clear? Let's say this. Can you see?
Yes, sir.
And the volume of this is given by small v.
Small b.
Clear? Clear?
Yes,
Now the question is, if there is n number of particles sitting over here. Clear? N number of particles which are sitting over here. What is the probability of particle being found over here? Clear? That is the question.
Yes, sir.
So first we start with P. P is what? The probability of each particle being over here. And Q is the probability of particle not in the box. Clear?
Yes, sir.
And that is for a single particle. Clear? Probability of a single particle, this is. So according to a binomial distribution, the probability distribution can be written as what? N factorial
Trivial.
divided by
By
n factorial
Trivial.
n minus n factorial p
To the power
by
n.
p to the power n q to the power n minus
N
n.
minus n.
Okay. And basically a p is small p is given by what? Basically small volume by capital volume. This is how we define the probability previously, if you remember. Do you all remember? Volume,
Yes, sir.
small volume by total volume. Clear? Now that will
Yes,
give
sir.
you this small p. Clear? And q was basically, q was what? 1 minus p. Clear? That is how you have defined p, q. So let's consider one problem. Clear? When your number of particles is, how many number of particles are there? Let's say we have 10 number of particles. Clear? And the volume of the small cube is how much?
Small
One.
b.
One. How much I have chosen there? Let's say 1 meter cube. 1 meter cube is too much. 0.1 meter cube. Okay. And the volume of the larger one is what? 1 meter cube. Clear? Is it clear?
yes, sir.
Yes,
Yes,
sir.
sir.
Now the probability, the small probability p is given by what? 0.1 divided by 1, which is basically how much? 0.1. Now the probability of particle not found in that box is basically given by what? Q, which is 1 minus p, which is 0.9. Done.
Yes, sir.
Now I am asking you a question. Now basically from the intuition, when will the probability will be largest? Probability of finding one particle will be more, or two particle, three particle, which will be more?
One
Now we
particle.
have 10 number of particles sitting over here. We have how many particles?
10 particles.
10 particles sitting over here. Clear? And we have a small box, let's say this one. Let's represent in the 2D, okay? I think it will be easier for you all to see. Consider this area as a volume. Clear? You have something like this. Okay, clear? Actually, this is the only area which you have considered. Now you are finding, now there are 10 particles which is sitting over here. Clear?
Yes, sir.
Now, what will be when will the probability highest? Probability of finding one particle over here will be highest, or two will be highest? Just guess.
One will be highest.
One will be highest. Why?
Uh,
Now, actually what I have done is, I have written, now this you can write in this manner. Can you write in this manner? 10 number of particle, probability distribution was 0.1, and this becomes 0.9. Can you say this one, everyone?
yes, sir.
Everyone? Indira, can you see?
Yes, sir.
Now we evaluated for each and every possibilities. Clear? The probability of particle not being found is given by when n equal to 0. Clear? N gives the number of particles inside that small box. Clear?
Yes, sir.
So
Yes,
when there
sir.
is no particle, the probability was how much? 0.34, which is correct, as the particle area or the volume of other remaining is larger. So that's why the probability will be slightly larger. Now the probability of finding one particle is this one. As you see, as the number of particles keep on increasing, the number of probability of finding the particle keeps on decreasing. Clear?
Yes, sir.
Now I have plotted that over here. Now this is the probability distribution of that particle. So in that small box, the probability of finding 0 particle is about this much, and the maximum is when of finding 1 particle. Clear? And it keeps on decreasing in this manner. Is it fine? That you can also evaluate. So probability of finding 0 was something, probability of finding 1 particle in this box was maximum. Clear?
Yes, sir.
Now the next question is, what will happen if I give you n very large? Into the
It will
power
be very much difficult to calculate.
into the power 5. 1, 2, 3, 4, 5, let's say, of this limit. Now it will be extremely hard to find for the factorial for this point. Clear? Now what we do is consider particular limit for this kind of problem. Now those two are called, one was here Poisson's distribution. For the Poisson distribution, what? N is very large, P is very small, N is very small, N mean is constant. Pn was a mean, no? Now this is the limit for their Poisson's distribution. Clear? Is it clear?
Yes, sir. Yes, sir.
N is very large, P is very small, N is very large. Clear? So in this limit, what we will get? Your probability distribution, binomial distribution, will drop down to your particular distribution called the Poisson's distribution, which is basically what? N to the power n divided by what? N factorial. Was it n factorial? N factorial, p to the power n, but there is an exponential factor. Was it something like this? Negative Pn. Sorry. It was negative Pn. Clear?
Yes,
At
sir.
this limit, what you'll get this n large, n small.
Yes,
Was the
sir.
n small or not? Is
N
much
was
less
small.
as compared to n, and p was small. In this limit, you will basically get what? This distribution, which is called a Poisson's distribution. So why this is helpful? Now can you see, you don't have to find a factorial of such a large number. It's just given by n to the power n. Clear?
Yes, sir.
Yes, sir.
Now suppose n is, let's say, 10 to the power 3. Clear? You don't have to find a factorial of that. And let's say n was how much? Much less. 10. Let's say n was 10. Clear? So 10 to the power 3 into 10 basically is what? 10 to the power 30, that you can evaluate directly. Can you see? Now previously what you will have to do? 10 to the power 3 factorial. So that problem is not here. Can you see?
Yes,
And
sir.
it is exponentiated over here. Yeah. Is it fine?
Yes,
Let's
sir.
try one.
Now a second kind of distribution is called a what? Gaussian distribution, which is come,
Sir,
yeah,
we could have tried one
yeah,
example, sir.
what?
We could have tried one example.
Which?
Poisson distribution, sir.
For the Poisson distribution, you can do the same question. Do the upper one.
Yes.
Clear? Do the same, whether you'll get the similar answer or not. You just check.
Yes, sir.
Now send it, do it and send it. Send it by tomorrow. Clear?
Yes.
You just check for this three. Whatever we have done with our binomial distribution, you do it with your Poisson's distribution and also with your Gaussian distribution. Clear?
Yes, sir.
Now the Gaussian distribution is given by when n is large and n is also large. This is the most important distribution in your statistical mechanics. This is what you encounter again and again. Clear?
Yes, sir.
Why? I will tell you. Because do you remember in Planck radiation and all, what was the energy given by?
E is equals to.
Have you done the Maxwell distribution previously in kinetic theory of gases?
Yes, sir. Maxwell distribution we have done, sir.
In kinetic theory of gases, I'm asking to everyone. So do you remember what was the distribution like? It was a velocity distribution, basically.
Forgot, sir.
Do you all remember Maxwell's distribution in thermodynamics, heat and thermodynamics? There we used to have.
So we have done, but I forgot.
Okay. Basically, it was given. It has a power of square. That was called a Maxwell's distribution as well. Clear? So at this limit, n is large and n is also large. This is usually what we want. In this limit, actually both we want. In this limit, what? The probability distribution is basically given by this. Clear? Now you don't have a factorial kind of thing sitting over here. Can you see?
Yes, sir.
And the mean is given by this. Mean is same for all the, and the standard deviation is given by this. Clear? Now let's do one example. Let's consider this example as well by considering both of the distribution. Clear?
Yes.
I will do one, you do the remaining. Clear? So according to Poisson's distribution, what was the probability distribution given by? The Poisson's distribution is given by what? Can anyone?
E is equals to.
What was that? Poisson's distribution was given by what?
Pn equals to 1 divided by
1 divided by?
root over 2 pi.
No, that was Gaussian. Before that.
1 was there, sir.
Pn equals to n factorial.
N factorial, no, it was n to the power n, no?
N to the power n divided
Okay.
by
Okay. N factorial.
small n factorial.
Okay.
P to the power n.
P to the power n. Okay.
E to the power minus
Right.
Pn.
E
Capital
N.
N.
Okay. Now let's consider for our previous case when n was how many number of particles was there? 10. 10. Do you remember previous question?
Yes, sir.
And probability was 0.1. Probability of finding a particle in that box. Clear?
Yes, sir.
So this basically it will be given by what? N is 10 to the power. I will do one example. So probability of finding 0 particle. Clear? In that box, small area, in small volume, sorry. n to the power 0 divided by 0 factorial p to the power 0 e to the power negative 0.1 into 10. Clear? N to the power 0 is 1, 0 factorial is 1, p to the power 0 is 1, 1 into e to the power negative, e to the power negative 1. This is how much you will get. Can anyone find me how much this will give you? E to the power minus 1. Indira,
Yes, sir.
how much will get e to the power minus 1?
E to the power, sir. E to the power minus 1 only, no, sir.
E to the power minus 1. Use the calculator and just tell me the answer.
E to
Sanjeev, do it.
Yes, sir.
Zero 0.36.
0.36. Okay.
0.36789
0.36.
79741.
Thing.
हमारे बीटा बाउंसर.
Okay, done. Now, if we compare with previous one, previously how much we get? 0.348. Clear?
Yes.
Previously, by using binomial, how much we got? 0.348. Clear? Now it's very close. So that's why even at this limit of only 10 and 0 particle, it is coming over this. Clear? Now, if the number of particles is extremely large, this distribution will be even better. Clear? Now you do for the remaining distribution for p equal to 1, so on and so forth. Let's do the similar example for the Gaussian itself. For the Gaussian, what was the value? Can you tell me?
One by root over.
Yes, sir. 1 by
1 by root over 2 pi something. After that, Pn.
P other.
P,
No, sir. N.
N, small n or capital
PQ.
N,
Capital N.
capital N,
PQ.
PQ,
E to the power
e to the power
N minus NP. Small n
n minus np.
divided by
Don't worry, I'll just write it.
E to the power minus
E to the power minus n minus np divided by what? Divided by what?
2n PQ.
2n pq
Nothing but the whole square.
whole square. Whole square. Okay. Now let's do for this one was valid when n is large and n is large but not comparable to n. Clear? So still let's use for p equal to 0. Now it is not comparable, it's completely off, but still let's do. Yeah. 1 divided by it will be how much? N was 10. 2 pi into 10. P into Q is 0.1 into 0.9. It will give you 0.09 you will get, no? 0.09 if you multiply this two. And after that, what you will get? E to the power n is 0. So it will be negative np whole square. Sorry. Basically, it will be 1, no?
1 minus. Yes, sir.
1 whole square minus 1 whole square divided by how much? 2 into 0 pq. 2 into 0 into actually 0.09. Clear? Now here you'll get certain value, but e to the power negative 1 by 0. Do you get something like this?
Yes, sir.
If you check this, something to the multiply 0.
So that is
So e
1
to the power,
square, no, sir? Hello?
yeah,
So that is 1 square, no, sir? Above.
1 square
Minus 1.
minus is already sitting over here. So basically it will give you
Yes, sir.
something e to the power negative infinity. You'll get something like this.
Yes,
Yes,
sir.
sir.
And e to the power negative infinity is how much? 0. So probability of finding particle over there is 0.
Zero.
Clear?
Yes, sir.
Yes, sir.
So that's why we didn't get the correct answer over here. Did you notice why we didn't get? Because this distribution is valid when n is comparable or is large, when n is also large. Let's say 6 or something. Would you like to do it for 6?
Yes, sir.
Let's do it for 6, okay? Then we can check whether it will be close to a binomial distribution or not. P6 you have to find. Now n is also large and q is also large, not large but just comparable. 2 pi, n was how much? 10,
Six.
and it will give you 0.09, isn't it?
Yes,
And
sir.
after that, what you'll get? E to the power exponential, e to the power negative, what? 6.
And minus.
6
Yes, sir.
minus, this will give you 1 most probably, divided by 2 into 6 into 0.09.
And 9.
Now if you evaluate this, how much you'll get? 2 pi into 0.9 and exponential of how much? 5 square divided by 5 square is 25. I'll just write 25 for 25 divided by how much? 6 2s are 12, 12 9s are 108.
108.
Is it?
Yes,
Yes,
sir.
sir.
So it will be 0.108. So you just find it, how much you get? How much you got?
For doing.
Okay. All this distribution are normalized if you remember. All the binomial distribution are normalized if you remember. So that's why your probability will be always less than equal to 1. Positive and less than equal to 1. Done.
9, 4, 4.
Hmm. Should I do it?
Yes, sir.
Done.
What I am learning.
1 divided by square root of what? Square root of 2,
5.
2 pi into 9. Yeah. This will give you how much? 0.13298 times. Now exponential will give you how much? E to the power negative 25 divided by 0.108. This will give you how much?
Minus 231.481. Hola.
To the power, I think having it. Just wait.
e to the power
What was the distribution? 2npq.
0.108.
How much you got?
Mistake. Where?
No, I think it's fine. Everyone got the correct answer? You got the answer? Everyone got the answer.
No,
So
sir.
it was coming out to be how much? 2.94
Yes, sir.
into the power minus 101 or something. Clear? So roughly this also tends to what? Tends to 0. To the power of this much. Can you see? Because it's exponentially decreasing at this rate. Okay, fine. This is what you got. Now I think it's fine.
Yes, sir.
So for this distribution, what we will be needing? We will be needing something where here n is also large, and even here n is also large. Now let's consider the particle being n being how many? 1000.
Yes, sir.
And n being how much? 100. Clear? If you consider this kind of limit, what you'll get, then you'll get a finite probability. Clear? Is it fine now?
Yes, sir.
Okay.